Thank you to O'Reilly for having me. It's good to see some people. It's starting to get later in the day. My talk today is going to be about some work that's very much in development at MapD, and it's really to make Python a first-class citizen within the MapD environment. And so this talk, I'm going to discuss first what MapD is, and then I'm going to talk about some of the work that we've done, and then do some live demonstrations towards the end. The goal of my talk is really more to put this out in the open and see what people think about it, get feedback. Even if you're not a MapD user, certainly you're most likely a Jupyter user. So I'd love to just really get feedback. It doesn't have to be during the question and answer session. We can do it privately if you'd like, or please ask any questions. So that's what I'm going to do, is just kind of go through some of these things that we've been working on. So here's my agenda. We're not going to spend too much time on the introduction. We'll spend a little bit more time about MapD. And then, as I said, we'll have some live coding examples as well. About me, so I joined MapD roughly 5 months ago as a senior developer advocate. And basically that means a lot of things, giving talks like this one today, going to meetups, writing blog posts, but also doing engineering work internally. I sort of laugh that I probably have the most bug tickets issued for any non-person on the engineering team, just from trying to do things, breaking things, figuring it out. I'm a contributor in several open source communities, so besides Python, I also do a lot of Julia development and some R development as well. And so I don't necessarily have a preference other than Julia, but Python works very well too. And then from anything that you see today, please feel free, as I said, to come up afterwards if you want to chat, or if you have questions later, or if you've tried MapD and you get stuck on something, please feel free to contact me. I'd love to help you out. That's part of my job, is really to make sure that our community users succeed in whatever it is they're trying to do with MapD. Thanks, Aaron. So what is MapD? MapD is a GPU-accelerated SQL and rendering engine. And so if you're familiar with what a GPU is, originally they were for rendering graphics on your computer terminal. But some enterprising people, roughly 2010, maybe 2011, realized that in the same way that pictures are two-dimensional matrices of pixels, you could just as easily represent most of machine learning and analytics as two-dimensional or one-dimensional vectors. And so CUDA was born. NVIDIA started building much more powerful data center class hardware, and that's sort of where MapD was born. And so MapD fits in very much in the analytics realm. On the left-hand side of this diagram, you'll see we have your streaming data, your data at rest. So you can think of these as maybe your Hadoop cluster, files that you have, whether they're CSV, Parquet, any of the major data formats. But the point is that it's data that you're not necessarily doing anything with. And then MapD fits really well in the middle area of, you have a data set, it may be too large to do on your local computer. It may be too large to do easily with a Pandas DataFrame or sort of standard methods that you're used to. And so MapD itself is a database, a SQL engine, but it's much more than that. And so because we have all the power of GPUs behind us, we can use them to not only do distributed calculations very quickly, but also to render graphics, right? If it's a graphics card, we can actually go back and render all of our visualizations that way. And so what does that imply? Well, if you've ever tried to do large-scale visualization in Jupyter, one of many things can happen. One, it can crash your browser. So if you try and stream 100,000 or 1 million data points to your browser, you'll eventually run out of CPU RAM. You'll get the frowny face in Chrome. And that's somewhat expected, right? Because if you were keeping your data somewhere else to begin with, why would you be able to bring it locally and visualize it? And so MapD has actually taken the opposite approach, and you're going to leave the data where it sits. You're going to render your million points or a billion points as a PNG and then send it back to the browser. And so no matter how much data you have, it's always going to be a 100 kilobyte, 200 kilobyte amount of visual data that you're going to stream back. Okay, and that really changes how you can do analytics. And so, as I said, MapD sort of fits in that really nice middle area of data analytics, some data storage, but we also interact with all sorts of different other programming languages. So JDBC and ODBC as general connectors, JavaScript, Python, R. You know, we try and be as flexible as we can to be a good open source company. And so, going back a little to make this a little less abstract, here's a picture of our main commercial product, which is called Immerse. And Immerse is very much a dashboard tool, but rather than do that, why don't I just go live to an actual Immerse instance. And so, if you've used BI tools in the past, you may say, well, like, I can do this in X, my favorite vendor tool. But there's something subtly different that I don't think people realize, and I hopefully after this can convince you that MapD is dramatically different. So the New York City taxi data set is a pretty well-known open data set. It's roughly 1 billion taxi rides over something like a 20-year period. And so if you want to analyze this using pandas, you're going to have a bad time. Whether you have enough RAM to hold a data frame like this, if you're trying to do any sort of operations on this using single-threaded pandas, it's just not going to work. Okay? And surely, if you wanted to do a visualization, you're going to have a bad time. Alternatively, you can use MapD. And so it may not be clear what's going on right now, but every time I move something on the screen, every other chart is re-rendering in real time, all billion points. Okay? And we can do all sorts of analyses because of this speed and power that you wouldn't be able to do in a different type of tool. And so just to prove that there's nothing sort of weird going on, we're at the Midtown Hilton, right? Okay, so in real time, we've drilled down into the 1 billion taxis and selected the 9.3 million records that surround the New York Hilton, where we are right now. Okay? And once you have this sort of power and ability at your fingertips, we can drill down even further. So maybe we're interested in Friday taxi rides around the Hilton. And just like that, we went from 9 million to 1 million taxi rides. We can continue to do this as many times as I can click on the screen, but the point being is we can visualize very large scale, and we can drill down to a single record, all because of the power of GPU. And so that's what MapD provides in terms of our product, but not everybody likes, not everybody likes the point and click. Not every analysis can be done clicking through whatever wizards MapD provides. And so the other thing that we've been working on is making Python a first-class citizen in MapD. And so we have 3 major projects to integrate MapD and Python. And I'll talk about all 3 and do some live examples of these. But we have PyMapD, which is our lowest level connector. This is basically at the lowest level where you might be using something like your ORM, so if you're using SQL Alchemy or any other tool like that, that's sort of at the level of PyMapD. The second project that we have that we just came out with was the MapD backend for IBIS. And so IBIS is a pandas-like API, but again, you will be able to do this over billions of records or whatever your hardware allows. And then the third thing that we've been working on, which is very, very rough, very much in development, is the MapD kernel for Jupyter. And so we have been trying a lot of things out with different types of widgets to make the experience more immersive within Jupyter itself, so that we can take that same that same experience that you're getting within our commercial immerse interface, but actually have that interactivity as well. And so now I'm going to actually go over to the demos. Okay. Is this big enough? Do I need to make the code bigger?
Make it
a little bigger. Okay. So here I'm running Jupyter Lab. And the first part, as I said, was PyMapD. And so this is our DBI compliant package that you can use just as you would use any other, whether you're using Postgres, MySQL, any other database that you're familiar with. And we have that same sort of the interactivity. And so we can go through, we can make our connection. And this probably isn't too new for anyone in the audience. And so we can do that same sort of thing. But the great part about this is we're still backed with the power of MapD. And so this isn't a misprint. It only took 13 milliseconds to run this query. There's no caching going on. And so we can go over that. Now, a count all really isn't that aggressive of a query. But as you can see, we can go through this, and we have that interactivity. Whereas, depending on the laptop or the desktop that you're using, you're probably going to be in the 5 or 10-second range once you start trying to use pandas to do these types of calculations. And as I said, because PyMapD is DBI compliant, you can actually pass your query strings directly through the pandas read SQL interface. Now, the thing about this is, and I've kind of glossed over it here, there's a lot of performance abilities that I really just don't have time to go into too much detail with PyMapD. But we actually have a functionality so that you can share memory. You can share GPU memory with Python and actually do all of your commands without transferring the data back and forth. If you do choose to use pandas this way, it will automatically transfer the data back to the CPU. So you do need to pay attention to what you're doing if you're going to do it this way. But in this case, because there's only, 50 or so stations in San Francisco for their bike sharing program, it's not going to be too big of a deal. So just to prove that it works, right? So 54.7 milliseconds. Again, it comes back as a data frame. Okay, we can look at it like that. And so that's our lowest level library. And so the second piece is IBIS. And so a lot of people don't like writing SQL. It's just sort of, my career grew up writing SQL, so I have no problem with it. Of course, I work for a database company now, so I really don't have a problem with it. But a lot of people don't like SQL. And IBIS sort of moves beyond that. IBIS has a very much pandas-like API. And so if you are looking for a quick speed up, it could be possible, depending on what you're doing, to push your data into MapD, use the same exact code that you would in pandas, but get a 50 or 200 times speed up because we're using the same exact methods. And so, again, we define our connection string. And then this statement down here, even without looking at the documentation or anything else, if you've used pandas before, you probably have a good idea of what's going on. So within our bikes table, I'm selecting the two columns up front that I want to use, the station name and duration. We're going to group by the station name, and then we're going to aggregate the sum. Okay? But you'll notice nothing actually seemed to have happened here. Okay? The thing about IBIS is that as a library itself, it's decided that for performance reasons, it's a lazy evaluated library. And so what I've done here is declared that I want a result, but I actually haven't done any calculations. And so what's interesting about this is IBIS will tell you how it plans to do the calculation. So as you're trying to go through and really squeeze out the performance of feature engineering or other types of analytics that you're doing, you can actually go through and assuming that you understand, of course, what all of this means. You can go through and try and pick out sort of the hot spots to really make your code faster. When we do want to execute it, we can call it execute, and then just to prove the point, okay, you do get the same answer, whether you use SQL, whether you use IBIS, it's just as fast either way. In the end, IBIS is generating SQL code for you and passing it to the database. And so to the extent that IBIS creates optimized SQL code, you get the same basic result. And so this is where we were up to about a week ago, providing programmatic access to MapD. And so now is really the part that I'm most excited about, but the place where this could just go off the rails as fast as possible is some more Jupyter-specific functionality. And so the first thing that we wanted to look at was moving beyond having to specify all of your query strings with all the weird quoting and escaping and everything else. If you've ever tried to do something that's a little bit more intense than the queries I'm showing here, you often run into this situation where you have a triple quoted string and you're starting to write things, and then you have to think about, well, I need single quotes around this column, and I'm trying to do a regular expression, so I need to escape some of these things, and it really gets unwieldy very quickly. And so the first thing that we want to do is to create a MapD magic. And what this is allowing us to do is to get past having to do all the quotes and actually be able to specify your query in line without any of the quoting. So if you've used other tools, other querying tools like Toad Data Studio or SQL Workbench or any of those things, you just write your queries like this, you get the result back. And so that's what we've aimed at here. Did I miss something? Like I said, just go right off the rails right in the beginning. All right. Told you it worked. And so, again, this isn't really an intense query in any way. It's really just to show that no matter what we're going to copy in here, you can use Jupyter Notebook or Jupyter Lab very much like an IDE, where you're just going to be typing in your queries, getting the results back. And just to sort of, hopefully this doesn't create any issue, but it doesn't even have to be well-formed. Okay? We've tried to make this as user-friendly as possible so that as you're writing and you're sort of manipulating your queries, that you don't have to, again, go back and make sure that you have all of your indents correct and everything else. So that's really our SQL magic. It seems probably more basic than it needs to be, but this is actually my favorite thing because it saves so much time not having to worry about all triple quoting and all that sort of weirdness that you can have. The second piece that we kind of went through was trying to actually do browser rendering. And okay, as I mentioned before, in our Immerse tool, we do have that functionality. All of our back-end engineers and even our front-end engineers have written all of the code that's necessary to pass, we use Vega for the most part, so pass Vega specs to a GPU, render it on the GPU, and then pass back the picture. And so that's how MapD gets very much of its fluid performance in the graphics realm. And so what we're hoping to do is do the same thing except with Jupyter Notebook. And again, this may work, this may not. This is the fun of these kind of talks. So we're going to do an Altair rendering. So Altair, if you're not familiar with this library, uses Vega as well. It uses Vega Lite So Vega is a wrapper around D3, and Vega Lite is a wrapper around Vega, and Altair is a wrapper around Vega Lite. Ultimately, you get to the point where your code is generating code, so that ultimately you can interact with your data at a high level instead of going through a JSON spec and making sure, again, that you have all of your data types correct and your quoting and everything else. Okay, so this is the query that I'm going to show, and again, very basic. We're going to have X and Y coordinates, so longitude and latitude, and then we're just going to have a basic ID to make sure that deduplication happens. And so when we go through this, again, we can render, we can execute our query and get the following. But again, we're trying not to stream data to Jupyter. And so in this case, we are actually going to do that. Oh, JavaScript error. All right, so everybody laughs, but I really prefer doing live demos. It's hard to use slides to talk about something that's interactive. So we'll go through again. Let me just submit some of these. Okay. And so here, what's hard to see is these points actually represent coordinates on a map. I didn't want to get too in-depth with that because, again, I was afraid it was going to break. But ultimately, you can stream all of this data to Jupyter. Right now, we've streamed approximately 1,000 points back, and so that is going to work. But you notice it took a while, right? It took whatever that was, 3 seconds, 5 seconds. And if I keep increasing the sample size, eventually this will stop working. And so what we actually want to do is we want to keep all of the data on the server. We want to render it with the GPU and send it back. And so we're all going to cross our fingers, and this is going to work. Who wants to bet this is going to work? All right, Aaron, I love your positivity. Okay. So while this looks slightly different than the picture above it, it does show the same point where we can render all of our points on the GPU. We can send back a picture. And so now, regardless of how many points we have, it's basically going to have constant time, right? Because the GPU is going to decide how it's going to render X number of points, but it's going to pass back a 200 kilobyte PNG. Okay. And so just to wrap up, as I said, this is very much in its earliest stages. Again, as I mentioned, this picture doesn't even match this one. The points match, but it doesn't have the axes, it doesn't have the other things. We'll eventually fix that. There's a very specific reason, and this has to do with how we use the rendering engine within Immerse, and that's why you're getting this transparent picture here. But we'll eventually fix that. But ultimately, what we're hoping to do is create an immersive environment where, whether you like to point and click, whether you like to write programs, that you'll be able to do really, really large-scale data exploration in instantaneous speed. And so with that, I'll open it up for questions. And if there's no questions, then so be it. Thank you.
Any questions? Well, the recording. So.
Hi, very interesting. So for this last part, can you also, or is there a reason you didn't want to render the image on the local GPU? Is it because the data is too large? And like, you're doing it on the server, you're doing the rendering on the server and sending the image over, but could you just render it on the local GPU also?
Right, so you could, but then again, you're still going to have your data transfer. And so much of the time that you're waiting for doing analytics is not the computation, it's actually the serialization, deserialization of your data. And so if I wanted to stream 1 billion points across the wire, right, it's going to take forever. So yes, it wouldn't blow up your Jupyter Notebook, but you'd still wait 20 minutes or whatever it takes to bring all that data locally to your local GPU. In this case, my MacBook doesn't have an NVIDIA GPU, and so it wouldn't even work in that sense. So any of you Mac users wouldn't be able to do that. But there's no reason you couldn't do it other than it would be wasteful. We're going to leave the data where it sits, process it, and then just return results.
Hey, thank you for the presentation. There's a library called DataShader. You're probably familiar with it. It works, I think, with the CPU on front end, but it allows to generate, like, obviously it doesn't help with the serialization and everything. Mm-hmm. The nice thing I like about it is that it essentially visualizes everything to the ND array of values, but then this last step of coloring essentially the map, you can do it or redo it to change your, say, colors. Mm-hmm. I wonder if if MapD supports the same, or is there any way to change this last step?
So if I understand the question, you're asking, can we render things but change the colors without re-rendering the picture? It may be possible. The thing about MapD is we wouldn't be anywhere without all the amazing open source libraries that exist. And so while we don't use DataShader, as far as I know, we don't use DataShader. There's nothing that prohibits it from MapD working that way.
I guess what I'm asking, is there any way to compute basically the same map on your end, but return it as an NG array instead of an image?
I'd have to look into it further. That's a pretty specific thing. Returning it as an array, that's how it exists before it gets rendered. So,
Also, with the speed of the query, we would just encourage you to run the query again and return a new PNG.
Well, I mean, it depends what you want to do.
Yeah, the time of it is the return time is not that great. So we have, I don't know. I would just say you could go up and change the color to red and rerun it, and it's going to come back in a couple hundred milliseconds.
So I was just looking up the Altair stuff. So if I wanted to circle some of those points and then do something in pandas, would that be possible? Like get the points back, get the references to the points or some identifiers for the points, do a query, and get like a pandas data frame that has those points in it and other data related to it. In other words, is there a way to do events back to Python from there?
From the picture, I think this really gets that's more of an Altair question, which is to say I don't know the answer. We can do that within our tool, and so let's do it on this one. So for instance, if you wanted to arbitrarily look at some place, like maybe you're only interested in if you're only interested in that part, you can do that within our tool. And so I think the answer is yes. At the most fundamental level, you would be able to do something like that. Whether you can do it exactly through Jupyter, through Altair, and pass it to pandas, I don't know, but I suspect it is possible.
I think I saw another question over here. No. Okay, no question. All right. Well, if there are no further questions, let's thank Randy once more and then go to a break. So thank you, Randy.
Thank you.